Hello and welcome to our video on interpolation and extrapolation and using the regression line to make predictions. So once you've got that regression line and the equation for the regression line calculated, this is one we've calculated in a previous video, you can now use it to predict other values. So the first one it's going to ask us to do is predict the price of a car that's 5.5 years old. So we need to go to 5.5 years, would be about here. And we can go up to the regression line and across to predict the value. So one way you can do it is by reading it off the graph. It's not a very accurate method. If we're trying to do this in a very accurate way, we need to make sure we use the equation. So our equation is, I'm going to write it in y equals form, 35,100 minus 3940x. So we're trying to find the age of a car that's 5.5 years old, so x equals 5.5. So we just substitute that into the equation. 35,100 minus 3940 times 5.5, and this will give us the price exactly. And you should get 13,430. So you can see that would link up with what we expected on the graph, but we could never have accurately found that data point without actually working it out. You can also do the opposite. So given the number for the y value, here we've got predict the age of a car when it's worth $20,000. So again, we're just going the opposite way. Start at the 20,000, go across to the regression line and down to see what your y value is. So it's about 3.5, maybe 3.6 years. But if we are trying to calculate more precisely, we need to use our equation again. First step, write your equation out. Take 3940x. This time we're going to make y equal 20,000. So 20,000 equals 35,100 take 3940x. And you can use the solve command on your CAS to solve this, and you will find that x equals 3.83 years, and remember we said it was about 3.6, 3.8. So I've put it to 2 decimal places or 3 significant figures. When we're making these predictions, there are 2 words that you need to be familiar with. When we're predicting within the range of data, like these 2 examples that we've done here, it's called interpolation. So that means our data points go from here, here, age of 1 year, all the way up to age of 8 years. So anywhere in between 1 and 8 years is called interpolation, and it's reasonably reliable to use the regression equation and the regression line because it's inside the data set. If you are trying to predict outside the range of data, it's called extrapolation. So what we're doing, if we go back this way, now you wouldn't want to predict for a negative age, but on another graph, if you're predicting back this way or up really high past the highest value here, then this is called extrapolation. You can still use the regression line, but it's not as reliable. Interpolation, pretty reliable. Extrapolation, not so reliable. An example of that is that here, if you went to here, you would get negative age, which is just weird. And it suggests that the price would increase if you had a car that had negative 3 years of age, which just doesn't even make sense, so not very reliable. And going up here, if we extend to 10 years and we extend this, we'll have to extend this line down to about here, we end up with the price goes into the negative. So at 10 years of age, a car would be worth negative $10,000, which again doesn't make a lot of sense. So for this data set, it's not very reliable to use extrapolation above and below the data set. You just need to know what these two words are and which one's reliable and which one's not so reliable. Thanks for watching the video.